Hi there and welcome. My name is Michael Kintenich and I'm a Microsoft Technical Trainer. In this video, we will embrace the state-of-the-art of authentication with Microsoft Identity Platform, your passport to seamless security. In today's interconnected world, managing identities and ensuring secure access is more important than ever. That's where Microsoft Identity Platform comes in. Picture this. You are a developer at a global company tasked with creating an application that employees around the world will use. The challenge? Ensuring that every employee can access the application securely, regardless of their location or the device they are using. In the past, this would have been a daunting task, involving complex authentication protocols and potential security risks. But with Microsoft Identity Platform, you can leverage industry standard protocols to authenticate users, manage users' access, and protect your APIs. This means you can focus on building great applications, knowing that the authentication is handled securely and efficiently. In this video, I will identify the components of the Microsoft Identity Platform, describe the three types of service principals and how they relate to an application object, and explain how permissions and user consent operate and how conditional access impacts your application. The Microsoft Identity Platform is a collection of tools that consists of authentication service, open source libraries, and application management tools. It enables you to create applications that your users and customers can log into using their Microsoft identities or social accounts. The Microsoft Identity Platform consists of several parts. To be able to leverage Azure Identity Management in or through your own applications, you need to register it in Entra ID. Your app will get its own identity. The recommended Microsoft Authentication libraries, the MCEL, are open source and provide built-in support for conditional access scenarios, single sign-on, experiences for your users, built-in token caching support, and more. MCEL assists with the various authorization grants and token flows used in different application types and scenarios. The Microsoft Identity Platform endpoint has OpenID Connect certification. It is compatible with the Microsoft Authentication libraries or any other library that follows the same standards. It uses scopes that are easy to understand following the industry norms. OAuth 2.0 and OpenID Connect standard compliant authentication service is enabling developers to authenticate several identity types, including work or school accounts provisioned through Microsoft Entra ID, personal Microsoft accounts like Skype, Xbox, and Outlook.com, or social or local accounts by using Azure Active Directory B2C, or the newer version, social or local customer accounts by using the Microsoft Entra External ID. For developers, the Microsoft Identity Platform offers integration of modern innovations in the identity and security space like passwordless authentication, step-up authentication, and conditional access. You don't need to implement such functionality yourself. Applications integrated with the Microsoft Identity Platform natively take advantage of such innovations. Moving to the whiteboard, I will explain the app registration part a bit more. When you have an app service running on Azure and you would like to delegate authentication to your Entra ID tenant, so that all users logging into your website, contoso.com, need to log in with their credentials that are stored or part of that Entra ID tenant. If you want to do this, you need to register an application or the application, creating an app registration in the Entra ID tenant, which from the perspective of the app is then the home tenant because it's created in there. When you create an app registration, there's actually two different resource types created. The first one is an app registration, And when you set up an app registration, you get always a second in the specific tenant, which is called an enterprise application, or known as a service principal. Now, when you set up an app registration, you need to decide if this is going to be a single tenant or a multi-tenant registration application. What does it mean? A single tenant means that whenever someone wants to log into contoso.com, they can only do this if they have an identity in the home tenant. What's the difference between the app registration object and the service principal? The application object itself is something where you provide additional information about the app, certificates, a logo, terms of usage. And the service principal or the enterprise application is used to grant permissions to other Azure resources, like a key vault or a database. If you need access to any of those, you will grant access to the service principal, not the application registration object. That's the reason why we have two of these different items. So what if we change this now to a multi-tenant scenario? So instead of single, we have a multi-tenant, which, by the way, you can change after the creation. So you can decide when you create it, but you also can change from single to multi or the other way around whenever it is already created. So multi-tenant means that even if someone completely externally from another company logs into in their browser to contoso.com and they have their own tenant, which has nothing to do with your tenant, they allow, with multi-tenant configuration, you allow them to authenticate against their tenant because there's an implicit trust relationship between all Entra ID tenants. And what happens when the first user logs in and uses that authentication piece, they get their own enterprise application created in their own external tenant. And only this, there's no application registration object, they will just get their own service principal. And now the administrator of this external tenant can go ahead and use the same approach and allow for this service principal now to access a database in their subscriptions. So that's the difference in between where you have multi-tenant versus single. And with multi-tenant, you always have that one application object that is a global object. There will always be one per app registration, per application, but you will have for each tenant where your application is used, where users ever logged at least once in, you will have one service principal in each of those tenants. And there's always a one-to-many relationship to these different objects. The Microsoft Identity Platform supports two types of permissions: delegated permissions and app-only permissions. When apps have a user who is signed in, they use delegated permissions. For these apps, either the admin or the user agrees to the permissions that the app asks for. The app gets permission to act like a signed-in user when it makes requests to the target resource. App-only access permissions are for apps that operate without a user who is signed in, such as apps that run as background services or daemons. Only an administrator can agree to app-only access permissions. Consent is the basis for applications in Microsoft Identity Platform to access required resources or APIs. You will also need to know how your users get access to your app or API if you're setting permissions. There are three different consent types: static user consent, incremental and dynamic user consent, and admin consent. In the static user consent scenario, you have to declare all the permissions your app requires in the Azure Portal's app configuration. If the user or administrator hasn't given consent for this app yet, then Microsoft Identity Platform asks the user to consent at this point. Static permissions also allow administrators to give consent for all the users in the organization. Defining the app's static permissions in the Azure portal makes the code neat and easy, but it also creates some potential problems for developers. When the user signs in for the first time, the app has to ask for all the permissions it might ever use. This can result in a lot of permissions that make end users reluctant to grant the app's access on initial sign-in. The app has to list all of the resources it might ever use in advance. It's hard to make apps that could use any number of resources. With the Microsoft Identity Platform endpoint, you can request permissions dynamically instead of using the static permissions defined in the app registration. You can start with a minimum set of permissions and ask for more as the customer uses more features of your app. To do this, you can indicate the scopes that this app needs at any time by adding the new scopes to the scope parameter when requesting an access token, without the need to predefine them in the application registration information up front. If the user hasn't consented to the new scope added to the request, they are asked to consent only to the new permissions. Admin consent is needed when your app requires access to some high-level permissions. Admin consent makes sure that administrators have some extra checks before giving apps or users permission to access sensitive information or data from the organization. An admin who grants consent for an app on behalf of the whole organization still needs the app to have the static permissions registered. Add those permissions for apps in the app registration portal if you want an admin to consent for the entire organization. This reduces the steps that the organization admin needs to take to configure the application. On the slide, you have an example request of an app that requires permission to access the user's calendar and to send email on behalf of the user. The scope parameter is a list of delegated permissions that the app is asking for, separated by spaces. After the user types in their credentials, the Microsoft Identity Platform looks for a record of user consent that matches. If the user has never agreed to any of the permissions that the app is asking for, and if the administrator has not agreed to these permissions for the whole organization yet, the Microsoft Identity Platform requests the user to give the permissions that the app is asking for now. Next, I will demonstrate an app registration and how to implement an interactive authentication flow by using the mcell.net library. In this video, I will walk you through how to create an app registration and implement an interactive authentication by using the Microsoft Authentication Library for .NET, the mcell. The plan is to use a local application that I have on my system to log me in with my user credentials in the tenant that my user lives in. But for this to be able and that my application gets its own identity, I need to first register this app so that it gets its own identity in the Microsoft Entra ID tenant that my subscription trusts right now. So let's go and create one. So in my Entra ID tenant, I'll look for the app registrations down here. And with this, I can create an application registration. So we'll call it AZ-204 app reg. And with this, I will go and follow the rest of the configuration, which there's not really a lot that I will use in here. The decision that I have to make is this going to be an application that lives just in a single tenant and allows only accounts from that single tenant, which means that only identities from within my tenant will be able to use this. So Spark possibility only. Then I can switch this either now or later to multi-tenant, which means that everyone who has a tenant on their own can use my app as well. The app registration will remain in my tenant, but each of the other tenants using the same app will have a representation of a service principal in their own tenant called an enterprise application. That's what I will show you later on as well. The plan is here to use a desktop app, which qualifies as a public client, means we're not trusting it with any secrets. And that is one of the platforms that the app registration supports. I can add additional ones if I need this. And I can, and I should actually, provide redirect URI, where I tell it where to send the request further once the identification of the authentication part is done. So let's use localhost for this one. Depending on what protocols and what, let's say, mechanisms you use, you might want to use a specific, let's say, listener in here with a specific port configuration. Check out the configuration for the guidance on this, because there's very easy step-by-step tutorials where you can just select the type of application you want to use, and then it will automatically configure the correct redirect URI for you. So that's all for now. There's not a lot more that I can configure at that point with an app registration, but once it is created, there's a lot of more things that I can configure. Now, this is the app registration. It has lots of different IDs for the client, the application itself. That is important. That's what goes into my code later on. An object ID, which is a representation of that enterprise application, the service principal I talked about, and an ID for the tenant itself. So this is the ID for that Spark possibility tenant that I have now this created in. There are a couple of other things that you can do. From here, you can add branding and other properties, like where can we find information about this application. You can upload a logo, terms of service, privacy statements, all of this that someone might be interested in to decide if they want to consent to this app using your rights or not. What you also can do is you can configure app API permissions. Every app registration will automatically get the right to access the Microsoft Graph API and provide user read permissions. And that is a so-called delegated permission, meaning if I will then later on log in for this application object with my credentials, I will get automatically Microsoft Graph user read rights for this. So for the sign-in user, I can then read my user profile. And an admin consent is not required, meaning I can decide this as a user. I don't need to require an admin to consent first. That is important to understand first, because we are going to get an access token for this particular use case where I would like to have that user read permission. Now, before I go to the code part, let me show you the enterprise application I talked about. So app registration was what I just did. And with that, I got also an enterprise application created for that same name. So this looks a little bit different. It's a different kind of resource. Has also application ID and object ID implemented in here. Application ID is the one from the application registration. Object ID, it's its own. And from here, I can assign roles and decide who is an administrator for this. I can assign other information for an application proxy, self-service, conditional access, and a lot more things. So as I said, this is the representation, a service principal that will be in each of the tenants where my application will be used. Right now, I can only have one because I selected single tenant. Now let's go back to the app registration and let's go and have a look at the IDs that we talked about. So as I said before, I will need the application ID and the tenant ID. This is what I need. Okay, how do I configure this? I have Visual Studio Code open here with the code already. That is taken from a template out of a tutorial. And in here, it's a .NET code. I have added the Microsoft Identity Client package. And I have it here asking me the IDs that I just said. Client ID is application ID, it's the same thing. So I will add this in here. And then I need to identify the tenant where we're logging in. These are not like secrets per se. Them alone is not really something that is causing a big issue. So you don't have to worry about this. But your application needs to reach out to the tenant and understand what kind of permissions or what kind of application are we talking about here, and then the rest will be handled in a secure OAuth supported OpenID Connect way with a standardized process flow. What that means is we will create a public client application builder using this with authority instance. So we're connecting to the cloud, to the public cloud instance. And from here, we will use this. This authority means that we're specifying this public cloud and then using the tenant for the app that we registered in. Here is also the URI, the redirect URI reused as well. And this is the scope where we say what kind of permissions we are asking for. And then how is the token itself? How do we get this? There are a couple of options. You can silently acquire this, but I will show you the example where I interactively acquire this. Means when I run this, it will open up a browser for me to log in. So I have saved this, and now I will switch to a PowerShell terminal where I just have the files in here. So you can just check that this is the same thing where I just open up the file. This is in here. So let's just see if it builds okay, but that should not be any issue. And then if that is okay, I will just run the application for now, and just it's a very simple example. So let's run this. So everything goes well, then exactly this happens. A browser window opens, it's an interactive approach. So it asks me here, okay, you need to log in. What is the account you want to use for this? So I will use that one account that is part of that tenant. I'm already signed in into the Azure portal, but I need at this point in time to get that permission. And now this is what the application registration itself gets to me. So from here, I could have configured the different terms and the privacy statements, provide the URLs, but I didn't. The name, a logo would appear here, and all these different things. And you can check, and you probably have seen these kind of things very often already. You can see what it wants. It wants me to sign in so that I'm able, or that application will be able to read my profile from it and then use something with it. So present me with information about it. Because I'm the first one who's using this application and I am an administrator, I can actually also give consent on behalf of the organization. Meaning from that point on, it is basically I have given consent for everyone, and the users can, depending how the configuration is made, decide if they want to allow that reading of the profile or not. But they don't need admin consent from that point in time anymore. So let's just do this, and then I accept it. And that should get me back to the application. So it says here, feel free to close it. And if I go back, there's the wall of text. That is just the token. You can tell here it's just token, and that is having all the information. Now with this access token, I could get access and read the profile that I have used. I would use this in code. I could use this as a REST API, providing a bearer token. There are different options, and that should just explain the flow that we have seen here right now, creating an application registration and then using this to get an access token with any public client. With conditional access, you can use one of several methods to secure your app and service through Microsoft Entra ID. Conditional access helps developers and enterprise customers safeguard services in various ways, such as multi-factor authentication, allowing only Intune enrolled devices to access specific services, restricting user locations and IP ranges. But how does conditional access impact your app? Usually, conditional access doesn't affect how an app works and doesn't require any updates from the developer. Only in some cases, when an app requests a token for a service without telling the user, does an app need code changes to deal with conditional access challenges. Specifically, the following scenarios require code to handle conditional access challenges. Apps performing the on behalf of flow, or apps accessing multiple services or resources. Single page apps using the MCell for JavaScript. and web apps calling a resource. The app and the web API that your app accesses can be subject to conditional access policies. An enterprise customer can change or remove conditional access policies at any time, depending on the situation. To make sure your app keeps working when a new policy is applied, implement challenge handling. In this unit, I identified the components of the Microsoft Identity Platform. We described the 3 types of service principals and how they relate to application objects. I also explained how permissions and user consent work together and how conditional access impacts your application. You now have unlocked the core features of the Microsoft Identity Platform, enabling seamless authentication and access control for your applications. By leveraging its authentication service, open source libraries, and application management tools, you are equipped to ensure secure access to resources with ease. Embrace the power of the Microsoft Identity Platform and safeguard your applications against unauthorized access today. Thanks for watching. Keep on learning.